Welcome to the lecture on circles. So the first thing we need to learn about circles is the general form of the equation of a circle. And this is something that you want to have memorized. So every circle has the form parentheses x minus h quantity squared plus y minus k quantity squared equals r squared. Now it may be expanded out beyond this, but if you have your circle in this very nice sort of factored form, it's really ideal because you can determine what your center and your radius of your circle are. And those are the two key pieces that you need to know if you want to graph a circle. So the center is going to be at h comma k. And notice that h here is the opposite sign from what you'll see in the parentheses. So if this is minus 3, then you'll want to use plus 3. If this was plus 2, then you'd want to use negative 2. And the same goes for the k. It's going to be the opposite sign for k and the opposite sign for h. The other thing to notice is the radius. You're going to get a constant over on this side of your equation, and that constant is the square of what your radius is. To find out what the actual radius is, you want to take the square root of that constant. So let's practice this just a little bit. If you are told that you want the equation of a circle having radius 2 and a center at negative 7 comma 6, then what we're going to do is convert it into this nice general form. So my center has an x value of negative 7, so in these first set of parentheses you want x minus that x value squared. And remember, opposite signs. So if I want my center to be at negative 7, then I need to see a plus 7 in those parentheses. Likewise, if I want to get a y value of 6, then I need to see a y minus 6 quantity squared so that I get the right signs. And finally, on this side of the equation is going to be your radius squared. So if my radius is 2, 2 squared would be 4, this now becomes the general form of the equation of my circle. Now you could FOIL all this out and kind of clean it up. If you did that, what I want you to notice is that this circle would have an x squared in it plus a y squared in it. And you might also have an x and a y term and another constant as well. But what makes something a circle is that it always has to have an x squared term plus a y squared term, and the coefficient of the x squared and the y squared terms always match if you're talking about a circle. So if you look at the equations on this next page, I know just by looking at these that they're circles because they all have x squareds and y squareds. There's addition in between the x squareds and the y squareds, and the coefficients match between the x squareds and the y squareds. Here the coefficients are both 1s, here the coefficients are both 4s. If you did not have matching coefficients, or if you had a minus sign instead of a plus sign, then that would result in either an ellipse or a hyperbola, and you'll learn about those more in college algebra. So what we want to do on this first equation is graph it. So we want to graph this circle, and in order to do that you need to identify the center and the radius. So in this problem, it might look a little bit strange at first, but if you remember our general form for a circle up here, what we're looking for the center is x minus some number quantity squared plus y minus some number quantity squared. So if I look at my equation here, what's being subtracted from x? Nothing. So that means the x value of the center must be 0. What's being subtracted from y? Nothing. So I want to have a y value that's also 0. What about the radius? Remember, your radius is this constant squared. So we need the square root of this constant to tell me my radius, so the radius must be 5. Now to graph this, what I like to do is put a little dot at the center, 0, 0. Whoops, pressed a little bit too hard. So put a little dot at 0, 0, and then I just kind of count out 5 to the right, put a dot, 5 up, put a dot, 5 left, put a dot, and 5 down, put a dot. and then as best you can, and I'm not a very good artist, especially on this computer, try to draw the best circle that you can. Okay? So we're going to do that again on this one, but what we want to notice first is in that general form, if you look back up here, there were no coefficients in front of those x's or y's. So if you see a coefficient in front of your x squared or y squared term, you always want to divide through by it first before you decide what your center and your radius is. So in this case, I want to divide every term by 4. So simplify, this becomes x squared plus y squared equals to 2. So my center, just like in the last one, there's nothing being subtracted from that x or that y. So my center has to be 0, 0. And what's my radius? My radius is the square root of this constant. So in this case, it's not going to be so nice. It's going to be the square root of 2, which is about 1.4. So we're going to put a dot at 0, 0 for my center, and then I'm going to go approximately 1.4 to the right, 1.4 up, 1.4 left, and 1.4 down, and draw my little tiny circle. Okay? Now if you look at those last two, I didn't have any center other than the origin. What's going to be different on the next two examples, if you compare the equations, is these next two equations have x squareds and y squareds, so we know they're circles, but they also have some x terms, and the last one also has a y term. So what that is going to cause to happen is a shift in the center. So on these last two, our center's not going to be at 0, 0 anymore. It's going to be at something different. How do we figure out what that center needs to be? Well, we got to go back to that standard form again, and we got to rewrite those equations in this factored form. So how do you take something like this and put it into x plus or minus something squared? How do you take something that's expanded like this and factor it in? That's called completing the square. So that's exactly what we're going to do on this next problem. We're going to complete the square to figure out what the shift is in our center. Now, in order to complete the square, number one thing you want to make sure of is that you have a coefficient of 1 in front of that x squared and that y squared term. This one already does, but if it didn't, you'd want to divide through by that coefficient first before you start progressing through your process. So we already have our coefficient of 1. So now what I'm going to do, I think I just erased a plus sign there. Let me put that back in. Maybe not. We'll just make it a minus. So what I want to do next here is complete the square on just the x's. Okay? So I want to rewrite this as x minus something squared. So in order to do that, how does completing the square work? You know that the number that needs to go right here is always 1/2 of this middle coefficient. So 1/2 of -10 would be -5, and that's why I have that minus in there. So this needs to be x minus 5 quantity squared. Why does that work? Well, think about what this would be if you were to FOIL it out. If you were to FOIL it out, you'd get an x squared, you'd get a minus 5x, you'd get another minus 5x, which is this -10x, but you'd also get a plus 25. So in order to make this accurate, we would need to add in 25 to both sides to keep it balanced. So these three terms factored are exactly this expression right here. So I've added in the 25 to make it become the factored form. But as a result, it doesn't change the y squared at all, but it does make this new constant on the right-hand side become 25. So you do have to add in constants to both sides to kind of balance it out, and that's going to give you the correct factored form. Now that we have it in our factored form, we should be able to identify the center. The center is going to have to be now at +5. Remember, opposite sign from what you see right here. And here the y didn't have anything subtracted off of it. There was no y term. So the y value of the center is still 0. So now my center is at 5, 0. What's the radius going to be? The radius is the square root of the constant on the end, so square root of 25 is 5. So this is a circle centered at 5, 0. So put a little dot there, and a radius of 5. So I'm going to go 5 to the right, 5 up, 5 left, and 5 down. And draw my circle. Okay, let's try that process one more time on one more example. So this one, again, first thing you want to do is recognize that it has to be a circle, and I know that it is because there's an x squared and a y squared. It's addition in between them, and the coefficients of the x squared and the y squared terms match. So that makes it a circle. Unfortunately, we don't want coefficients. We want those x squared and y squareds to have a coefficient of 1. So the very first thing we're going to do is divide every single term by the coefficient 2 so that this becomes just an x squared. So we get x squared plus 6x plus y squared minus 4y equals to 3. Now notice that this time we have both an x term and a y term in the middle. So that means both the x center point gets shifted and the y coordinate of the center point gets shifted. And in order to figure out what those shifted values are going to be, you're going to need to complete the square. And we have to do it twice because we're going to have to do it once for the x's and also once for the y's. So here's kind of what I like to do. I like to give myself a little bit of space. I'm going to separate the x's, and then over a little bit farther over with a little space in between, I'm going to put my y's, leave a little space, and then leave that constant on the right hand side. And now I'm going to complete the square on just the x's. So since the coefficient is already 1, all I have to do is take 1/2 of that middle coefficient, which would be 3, and that means in parentheses this would need to be x plus 3 quantity squared. Now to make sure it's balanced, think about what this would be if you were to FOIL it out. You'd get an x squared, you'd get a 6x, but you'd also get a plus 9. So we need to add in plus 9 and balance it out by adding in that plus 9 to the other side as well. Now these three terms right here factor into that quantity. So we've kept everything balanced. Now we're going to do the same thing on the y's. So I'm going to add in here whatever I get for the y's. So to find out what happens to y, I want 1/2 of that middle coefficient. Half of -4 would be -2, so this needs to be a y minus 2 quantity squared. Now let's check. If I were to FOIL this out, I'd get a y squared, I'd get a minus 4y, but I'd also get a plus 4. So I have to add it in and balance it out by adding it to the other side as well. And now all three of these terms factor correctly into that quantity. But as a result of my adding in, I now have a new constant on the right hand side. 3 plus 9 is 12, 12 plus 4 is 16. So here's my nice general form. What's the center have to be? Remember to use opposite signs. The center has to be -3 for x, +2 for y, and my radius is the square root of the constant, so square root of 16 is 4. So I'm going to put a dot at -3, 2, and then I'm going to go right 4, up 4, left 4, down 4, and draw my circle. And that concludes our lecture on circles. Good luck.